this is week 6 and we're still talking about preventive maintenance. There's a short video I want to show you at the end of the class about preventive maintenance and carbon monoxide because it's related to combustion. If you are going to do any kind of combustion in a house, you have to know about carbon monoxide. So we are in safety PMs and we did the lab which we installed or wired 2 boilers. This is the second week we will do the wiring. So hopefully you are comfortable with that. Next week, after spring break, we'll do 2 weeks of troubleshooting. Troubleshooting should be a lot of fun. But remember all these little tricks here and there. So safety beam, you want to check that all the controls are working. The cat cell is cutting off on high limit. So when you set if it's hot water, you set the high limit and make sure you monitor the temperature and make sure the system runs on high, cuts on high limit. When you want to test your primary control, you want to cover the cat cell and wait for it. It's going to run. It should cut out in 15 seconds. If it doesn't, something's wrong with the cat cell control. High and low cutoff points. Steam is very critical. Make sure you wait for the steam to start rising and to build pressure. Once it reaches 2 psi, it should cut off. Otherwise, something wrong with the pressure cutoff. And if it's faulty, you will have to change it. Check the relief valve that it operates and it has been maintained. What is the expiration date on it and what is the last preventive maintenance? Every year you should turn on the steam, have it running, and check the relief valve. How do you check the relief valve? Press the lever, pull it, and it should let out some steam. If there is no steam, it's not going to have a lot of pressure, so it's not going to let the steam out. What is the standard pressure set for relief valve? Huh? No.
Can you say that again?
What is the pressure? Safety pressure set for relief valve? 15 or 30? 30. Remember, 30. What is it, Mark? Relief valve pressure? 30. 30. Okay. It's not. It's the standards. If it changes, it should stay on. But this is. If you never have relief valve, you put it at 30. Perform a smoke test. We'll see how to do a smoke test. It's very low tech instrument. Check for carbon monoxide and check around the equipment for leaks. When we say leaks, it means oil leaks or water leaks or even steam leaks. If you have steam leaking somewhere where it's not supposed to, point that out. Contact a plumber and have him come and do the plumbing for steam. Efficiency. Use a combustion analysis kit. We have 2 types of kits, either a wet kit or also called a mechanical kit. Do a combustion test, and you can use an electronic combustion test. This is an electronic combustion test. It comes with a small little printer. It does the combustion test, temperature, and efficiency, but the only thing that it doesn't do is the smoke test. These instruments are expensive and need to be calibrated every 6 months. So this is something you have if you have a company that will do the calibration, and you can replace it when you go on the job. And the mechanical kit lasts longer, requires less calibration, you can do the maintenance yourself. So they have all advantages and disadvantages. Change the nozzle and filter and check for unusual problems, white residue or excess debris. The white residue is usually caused because of bacteria. If you have bacteria, that means you have what? Water. Thank you. There's water in the tank. Go check the water, drain the water, make sure it's clean and inspected. These things, even though everybody says it should be done annually, not everybody do it. People don't check for water. They will just fill the tank and move on. Be the one who actually check for those issues because if over time they will cause a problem. Equipment integrity. Look for exposed parts of the burner. Everything should be covered in the right place. Wire nuts. We have experienced some issues with wire nuts. The wire nuts is connecting 2 wires, but there's not an actual connection. Maybe the 2 tips of the exposed wire is not connected. Loose wires. You don't want the wire to be loose. Tug on each wire and ensure it's mechanically connected. Look for uncovered boxes. Check for excess noise of vibration that could come from the fan. inducer fan can come from the motor. Something might have fallen in the inducer fan that has not been retrieved. So a small piece falling in the inducer fan, and it happens a lot. And over time it will rattle. Make sure to know where that rattling is from. Most of the time it wouldn't cause a problem, but you never know when this thing will fly off and get clogged and ruin your motor. So, vibration, leaky tubes, or old wires. This is very important. Check for old wires. If the wires are covered with fabric or paper, or it's very old or crispy, it's time to change them, or at least report them. Yeah, where you look, if you bend it and you feel like pieces of the insulation falling apart, that has been too old and it's time to change it. If you run your fingers through the wire and it sticks to your finger, you know, it's really melting and you should change that wire. Leaky tubes should also be changed, and go with a flashlight and inspect the tubes for kinks and bends. Cleanliness. Can we put the phones away, please? Make sure the area is clean around the boiler, especially around the intake. Where is the intake? Is so this area where you will have a lot of air coming inside the burner. So make sure the area is clean. There's not a lot of dust, debris, animal hair, boxes, because the air is going to go inside the inducer fan in this area, inside the tank. So you don't want this area to be dirty because it's going to be sucked in at some point and burnt, and it might clog your inducer fan. You also want to check that the draft door area is clean, there's no dust and debris in it. These are a set of tools you want to have with you before you go and do preventive maintenance. So make sure you have the right tools. Again, do not use adjustable wrenches to tie the nozzle line, because they don't give you the right grip, and a lot of times they strip the nut. So use the proper tools. Use standard wrenches. Adjustable are not good for this kind of job. Probably you see a lot of stripped nozzle lines because everybody's just don't have the energy to go and get a proper wrench. They use an adjustable, and the adjustable is not going to fit very well. It's a little bit loose. You try to tighten it up, and it's not going to grip. It will slide, and one time after the other, you will strip the nut.
There's a certain amount of torque on the nut.
No, it's hand tight. Don't go too crazy because again it's copper, so it's very soft. It's a pliers. You get a set of wrenches. You'll need those to remove the inducer fan and some motors. Screwdrivers, both Phillips and flat. Nut drivers. Those are very convenient for these kind of nuts. It's very convenient. If you notice, they are, I think they are 3/16, and they have a flat head to them. Usually the flat is not going to grip very well, so it gets frustrating. It's easier to have them with a nut driver. It's good to invest also in a nice, small little powered screwdriver, and get one with all the attachment. It makes things easier, and also it has the proper torquing power. Two cutters, those for oil lines, in case you bent one of the tubes or it's leaky, you want to check it on the spot. Flaring toolkit, that's something you want to have with you the whole time. Again, any leaks, you can fix it on the spot. Have a flare joint and put them together, cut the pipe and replace it. Flashlight is very important to see inside the chamber. It's very dark in there, and also look at the heat exchanger to make sure it's clean. So flashlight is good. It's important. Mirrors are important, so you can see an area where you can reach. Jumper leads. Those are very important, so you can jumper the thermostat. Also get a set of alligator clips with a plug. Those are these ones. So this is something you can buy from Home Depot or any warehouse. And you put those with a power surge cord with a switch. So you can plug it in, plug it to the motor. You can test the motor by itself. You can test the oil valve. or you can test the igniter. So they're very convenient, and make sure they have the sleeves so they do not touch. And again, always keep in mind that you're working around oil and gas, so be careful. Tape measure around 12 feet minimum, so you can measure distances. Drill with bits. If you need to drill some holes and put some fasteners, that'll be a good idea. So this is a list of tools you need to get with you for being. Test equipment, pressure gauge. We use the pressure gauge, right? We know how they work. Where do you use a pressure gauge?
Check pressure.
Where?
Oil burner.
Where? Where do you put it? Huh?
Right where there's a gauge at?
The outlet of the pump. So you're going to take this nozzle line out and put your pressure gauge. And what should it indicate? How many psi? 100, 150. And you turn off the pump and it should drop by 20%, 15 to 20%, and stays there. That's a good way to test the pump.
When it's off?
Huh?
When it's off, it's on.
Yeah. And also, you can use, if it drops after you turn it off, it means there's a leak in the system. It should drop and stop. If you drop and keep dropping, something's wrong with the system, there's a leak. A vacuum gauge, that is going to be in inches, and you put that in the inlet of the pump, where the oil line is. What is the purpose of the vacuum?
Vacuum out the air
No.
or oil or whatever.
No, it will tell you how much suction the pump has based on the oil line. And there's a formula in the book if you need to tell you how much of vacuum do you need for that pump, how much suction does it have to be able to pull the oil all the way from the tank to the pump.
Suction.
Yeah, because you're required to have some suction, not a lot. Because usually those things are gravity fed, they're not pulling from a lot of pressure, but they're required to have some suction for the resistance of the pipe and also for the distance. Electric multimeter, you need to have this with you the whole time. Complete efficiency test kit, and shaft vac with brushes. Huh? Shaft vac is a vacuum. Shaft vacuum, and it's also called a soot vacuum. If you saw us yesterday, we were vacuuming with inside the tank. The hose is made out of fiberglass. I can show you that thing once you want to see what it looks like. So shaft vacuum, it's also called a soot vacuum. It's important to clean the debris inside the tank. And brushes are important because you want to brush the heat exchanger while you vacuum. So the procedure to do, we don't have any dirty boilers here, but we can do a mock simulation where you just like put a mask, glasses, you brush, and you vacuum. It's a one-job person, but it's easier with two people. Cleaning supplies, wire brushes. Those are very important to clean the vent and also to clean the heat exchanger. Cleaning brushes, gloves, plastic gloves. Those gloves are kind of like mechanical gloves or heat-resistant gloves, and plastic or latex gloves. Rags and old newspaper to spread before you start your work. And it's good to have big pans because you don't want to drip any oil on the floor. Usually the floor is made out of cement. It will soak the oil quickly, it will stain, and it will show that there was some diesel on it. Towels, and your best friend, WD-40. Everybody should have WD-40 with them the whole time. Two tools. Always the movie, Gran Torino. So this is the tools you need. Adjustable wrench, duct tape, WD-40. That will fix most household problems. So WD-40 is very important, especially if the equipment is old. Trying to get something loose, it's very helpful to spray it and wear a little bit, then try to loosen things up. Okay. Questions? Tune-up procedures. So the first thing is customer interview. If you're just doing a tune-up, ask about the history. What was the last time you turned it on? Who came here, did some work on it? When did you fill the oil tank? What is the current problem, if any? Check the thermostat that is running and it's not clogged. And check also the location of the thermostat. Make sure there is no light around it. There is no equipment, there is no TV. It should be by itself. Nothing should be around the thermostat. Why? Because it will affect the reading of the thermostat. If you put a light fixture next to it. Probably the heat from the light will affect the air temperature on the thermostat. Check the heat anticipator. That's something in all thermostat. You don't have to worry about that. The anticipator is in all thermostat. It will make up for the heat produced by the amperage inside the thermostat. So that's something you want to think about. Step 2, do a visual inspection. Put some old newspapers around it. Try to look around the tank. Record the filter model and number so you can see if you have it before you take it off. Do not take out any equipment without having a replacement. Probably you've noticed a lot of time you try to take out old parts, they break for many reasons. They've been there for too long, they're fragile, they have deteriorated, so you have to make sure that you have the replacement before you take anything out. Check the fuel pads for loose connections by hand, shake it should not be loose. Residue. Draft test for the fire and breach. You can do a draft test to see what is draft is the suction in the breach and draft. And check the wire condition again, make sure all the wires are sound. Blow look if they're loose, if they're making solid connection. Sometimes they're touching, but they're not really connected very well. Pull on it, it should not be pulled right away. Step 3, inspect the oil tank. How do we inspect the oil tank? Flashlight, go on the tank, check out the seams. There is no excessive rust, there is no moisture, there is no oil leaks. And check for the water. Get a dipping stick with the paste, stick it inside, and look for discoloration. Check tank plugs, cabs, and connections. Everything is sound, there's no vents opening, and there's no gauge that is broken.
Could you just use a dipping stick with some like oil on it or liquid on it? Or not liquid, but like gasoline on it, the water sticks to gasoline?
No, there's a special paste.
Oh,
So I'll change color
Okay.
once you dip it. Step 4, check oil lines, valves, and filter. Change the filter if you have a replacement. It's very similar to the car filter. Put a pan underneath, it's going to drip. Make sure you capture all the oil. Check the oil line for kinks, leaks, and deterioration. And check fittings, that they're tight, they're not loose. Sometimes they're loose, but they're still not leaking because the system is off. So make sure they're not loose. The fuel unit, change the pump strainer. Some pumps have a strainer right on top of them. Change the gasket. Bleed the line. Do you know how to bleed the line? Purge line. So this is your purge line here. You purge it. So you put a hose in here and loosen it a little bit. I've seen some people where the boiler is a very tight location, so they just open the line and put a pan underneath. That's not a good idea. Make sure you always connect the hose. That's why there's a knob in here. Put a hose, even if it goes up, there's enough pressure to pull it out. Do not put just a can underneath and try to bleed it that way. It will splash. It's a lot of pressure. So have the proper tool. Again, try to develop good practice. Don't look for shortcuts, because again, it gets one thing will lead to another. Take it step by step and designate yourself a lot of time. One thing I also learned from experience is learn how to estimate the time for that job. So if you say half an hour, then you realize it takes 2 hours, that's going to make you feel a little frustrated. Do not start something thinking that will be done in 5 minutes. Try to approximate the time, how long it will take you, and do not fit too much into small time. Let's say you have back-to-back jobs, you thought that 5 minutes will be enough to change the filter, then you find out it's a big job. So changing the filter usually requires more than that. Give yourself plenty of time before you start a job. Otherwise, come back and reschedule it. Don't work in the very tight timeline. Please let the nozzle install your pressure gauge. Check the gauge for pulsation. What does that mean? If you turn the pump and the pressure indicator is not constant, it goes back and forth, that means there's air in the line. Make sure the pressure is steady. Shut off the pump and check for pressure drop. It should be between 15 and 20%. Otherwise, the pump is faulty, or the pressure valve or the oil valve is faulty. So it should not drop too much. If it keep dropping, there's must be a leak in the tank, in the oil line. Or the leak could be in the nozzle. The nozzle is broken or is leaking. The nozzle, check the number and the model for the nozzle, match the number with the requirement. So before you take out the nozzle, take it out, look at it, and make sure it's the same as the outside. Maybe somebody changed it and they did not follow the instruction, and make sure they understand why did they change it, and go with the sticker on the burner. So this one should say on it how much. So this will tell you the nozzle here. It has the nozzle number and it has the pressure. So the nozzle has 1.35 GPH, and the nozzle, this is they give the model number specifically with an angle of 85. The pressure is 140. So always follow the sticker on the burner. If you don't have the sticker, what are you gonna do? You're gonna go with the model number and the brand, and you should find something. If you go with something that's older than 20 years, probably just stick with what's in there. You're not changing anything. Install new nozzle, clean, adjust the electrodes using the appropriate gauge for that model. If there is no gauge and if the model is very old, what is the distance? On the 1/8 of an inch. And clean and inspect the air tube and assembly. Step 7, look at the burner motor, housing, and fan. If there is an oiling point, lubricate with 4 to 3 drops with SAE20. There's some more, that's really old, I don't think you will see that a lot. But there's some kind of oiling point where you just put some drops of oil and you'll see some instruction on it. You'll see that actually in some burner motors and also in some inducer fan motors. Inspect the coupling. Clean the air inlet and fan with a small brush. This is here. These fans, again, get exposed to a lot of air, so you'll see some buildup. Take them out, clean them, wash them, put them back. What does the coupling look like? There's not one here. Coupling is plastic, and it connects the motor to the inducer fan to the pump. It's purposely made out of plastic, so it will not over torque. Once you over torque, you shred it, and it breaks. And it serves the purpose by breaking. Check the fan and motor for movement and fit. This is the pressure gauge check. Put the pressure on the outside, put the outlet, and turn it on. Transformer and cat cell. Check the wires, brackets, and position. Make sure the electrodes are making solid contact with the electrodes, bus bars. Make sure there are no wires being crimped. This is very important. A lot of time we crimp the wire in the wrong place, or we pull wires when we put it back carefully. Those sleeve connections, they get loose. If they're loose, what do? How do you fix this one if it's loose? It's not gripping. No, you go with pliers and just tie it. Unless it's broken. If it's not broken, then you have to change it. They get loose. Go with pliers and make them tight a little bit. Press on them and put it back. Make sure it's like it doesn't slide out and off easily. Wires should not be crimped. Again, never try to be pleased with just cutting things in and wires are not connected very good. When you put back the control in the junction box, make sure it's not touching the junction box. Make sure that there is no exposed wires between the sleeve connection and the wire. I've seen that a lot. You get more than you're supposed to, and there's a lot of exposed wire. That's an accident waiting to happen. Make sure there is all the wires completely covered and sheathed. Step 9, a flue pipe. What's a flue pipe? That's where the flue gases comes out. Remove the flue pipe and brush it. You'll see a lot of accumulation in there. Check the draft regulator for free swing. If there is, what is the free swing? So if this should be closed naturally, I should tilt a little bit once the burner is on. If you come in and the burner is off and it's this way, that means it's faulty. It should be balanced. It should be naturally closed. And make sure you push on it and it moves freely without being stopped.
That's a free swing, right?
Yep. And if there's a power venting, check for the clean the fan. Sometimes when the chimney is too short or too long with proper drift, you will need to put inducer fan to help with the draft. So if there's an inducer fan, probably in the back of the shed, you'll see a lot of inducer fans that put in the venters, and those will scrub your draft, but it will make sure that you have proper draft inside your floor. Heat exchangers and combustion area. Clean and vacuum the combustion and heat exchanger, not heat exchanger area. That's going to be on top of your boiler. There are plates you can move and go with a brush and clean them. And it's something that people do not like to do. It's a very hideous job, but it's important. Over time, this will accumulate a lot of soot, and that will cause the heat exchanger to lose efficiency. Use a soot brush if needed, and sometimes you need to use a saw to cut solid pieces and burst them out. Step 12, reassemble, seal, and fasten, and turn it on, and hopefully it will work. Otherwise, you're going to go back
Do it all over again.
and check what happened. So do it carefully in the beginning. It's really annoying that you put everything together, you turn on a switch, and nothing comes up. So expect it to happen. It will happen. Just be ready to go back and take it apart and see what did you do wrong. Fire the unit, jump with the thermostat. Over here, the thermostat is right next to you. In real life, the thermostat will be the second or first floor. So to shortcut the distance so you don't go up and down, you can jump on the thermostat either in the CAD cell primary control or in the aquastat, and it should turn on. Put a jumper and turn it on, and it should turn on. Step 12, do efficiency test. Before you do efficiency test, you should leave the burner off at least 10 to 15 minutes to burn any excess gas while existing in the chamber and to stabilize the temperature. We should aim for zero smoke. We'll do a draft test. Draft test is basically on the vacuum pressure, the airflow in the chamber. CO2 should be between 10 and 12%. Stack temperature should be around 350. And once it's running, take out the jumper. Don't leave it there because otherwise the system will be on the whole time. If you want to talk a little bit about the CO2 being 10 to 15%, what would the oxygen be? If the air is 20% oxygen and you have produced CO2 10 to 20%, 10 to 8%, so you consume 10% oxygen. So you can do a combustion test using either oxygen tester or CO2 testing. Step 14, I actually have a list for these on Blackboard, a checklist that you can print and take with you and save it, just to make sure that you did all those steps. Now the system is on, we will do a heating system check. If you have a water system, check the zone valve for operation, lubricate the circulator motor if needed, check for the expansion tank. So the system is running now, we're not done. So you're gonna go with the water to heat, we did that with the hot water system, the HB Smith. Make sure the pump is running between the limits, make sure it's producing heat. If it's warm air, clean the blower motor, check the air filter. Air filter should be changed semi-annually. Check for the tension in the fan belt, if there's a fan belt. Check the bearing for noise. It should not be too noisy. It should be just humming, but not noisy. Check the limits. This is very important. Checking the limits in all systems. Those limits are for a reason. If the system is turning on, those limits are supposed to turn it off and bring it on. So try to check the limits before you leave the site. For steam, the most important thing is to check the low water cutoff. How do we check for low water cutoff?
Wait till it drops.
You gotta turn it on and drain the system. And make sure it cuts off. That is very, very essential. Most of the issues with steam system comes because of the low water cutoff is not activated. And the low water cutoff can go bad because it's electronic. So turn the system on and drain the water slowly and see if it drops below the level and make sure that it does cut out the system.
Drain where?
Every steam system, every steam boiler has a drain at the bottom. Usually there's a hose and there's a small drain
In the basement.
in the basement. It's not that big a bucket. It shouldn't be more than 6 gallons inside the boiler. So drain the system. And it's a good idea to flush the system once a year.
So once you drain that, then you'll notice the sight glass start draining as well.
Yeah.
Okay.
And then you see also that it will cut off. And if you have an advanced low water cutoff, it will light up to telling that there is low water. So always check for the water system. For hot water system and for steam system, it's very essential that you drain the system. Who saw me last week draining some system and the water comes really black?
That was yesterday.
That was yesterday.
And also last week.
No, it was Thursday.
Yeah.
Oh, okay.
So we did that. So you drain the water comes really dirty. You want to change that periodically. What would happen if you don't? This will accumulate over time for hot water and for steam, and eventually it will clog the system. After a while, it will accumulate from a block, and the system will need to be cleaned and brushed. Also, the steam mattresses or radiators, after a while, they accumulate a lot of water in them that can be clogged because the opening is not big enough, and that could cause havoc. So you'll have to go there and clean them. So flushing the system periodically is very, very important. Clean the side glass. You can open it up. Clean it. Check the vents for any leaks. What are the vents? So when you turn on the system and you start to turn on, what does a steam system first do? The first thing it does, it hisses, right? You get all the hissing that's venting the air. So go around the house and make sure that all those little vents are not leaking water or vapor, or not like spitting. That means it needs to be changed. This is supposed to let out only air and not steam. So make sure they are not. Finally, clean up the work area, record any changes, replacement, notices that you have unreported to the owner. Usually, if you go to service a burner, you want to keep a report of what have changed in it. Leave something near the boiler, tag it or use it paper, what has been done with it. The few jobs that I did with boilers, usually there's a big report there with dates, who came, what happened, what changed, and that will help you or the next person who goes to the site to do the same work. So there's a video, 20 minutes about preventive maintenance. I would like you to watch. It's about the same stuff that we just did here.